In today's session, we'll be discussing on supervised learning. And within supervised learning, we will be discussing on KNN, K nearest neighbor classifier. Okay. So K nearest neighbor, it represents clustering. So you cluster on the nearest data points that you have, like nearest insertion, right? Let's say you have different data points. Okay. And you can also implement in savings methods of your unit, right? Imagine a salesperson visiting, like, different locations, right? A classic example, right? He would like to return to his office location or his home, right? So this will help in combining the trips. Okay. So the algorithms works. It selects the nodes at the depot. Okay. And then forms individual routes from the depot of each node. Okay. And even it can be implemented in vehicle routing problems. Okay. So here we can look at a similar routing problem that has been there. Like the vehicles, let's say in logistics department, you have the capacity of the machine, right? It could be of different sizes as well. Okay. The number of times the vehicle is picking up the material or the products from one place to another. Okay. So here the common object is the cost. Okay. To minimize the cost, basically. And in analytics, in supply chain analytics, is to minimize the number of vehicles to serve or to operate in that particular unit. Okay. So because of all these objectives, there are certain variants of vehicles also that are available. Okay. We can also look at clustering. So the optimized traveling distance can be obtained. Of course, you want to know the distance that the vehicle is been traveling. Okay. there are multiple areas where this model has been implemented. So we can group a number of vehicles or machinery in a unit, as well as different departments. Like you have the manufacturing unit, you have the sales or the service unit, right? Not just in the manufacturing unit, it can also uh, differentiate between the modes, like be it roadways, waterways, through air, right? Airway. So we know that KNN is a distance based classifier. Okay. What are the greatest similarities, or what are the behavioral similarities? Based on that, you take up this. Okay, it will also allow you to predict. And how do you find out the best value of K? It is always a odd number. Okay, you select the near optimal value, and K has to be the smallest. So it is said that the lesser the number of points, the better it is. The points you create to predict, right? Okay, and then if you look at the benefits, okay, it is KNN is also called as lazy learning, right? And if you look at the benefits, it it can use only the K value, that is odd number, okay, and the distance function. And this method is more efficient with smaller data sets. Okay, you can also look at support vector machines, right? Not in a KNN, however, eventually you can do that. And you can compare each result across each model. And you have to choose whichever model gives you the least error rate. And in a perfect world, we can look for the overfitting models. Okay. And again, that is in a perfect world where your data is all ready. So how do you figure out what is your K value? How do you know what method to perform? How is your model performing, right? And how do you know the optimal number of neighbors, right? In fact, you really do not know the number of neighbors at a high level, in a way. Okay. So how do you find out K? One is using the odd numbers. Okay. You can do it by fitting a KNN classifier for each number. And you can also predict, create predictions and evaluate the performance. Okay. And you can evaluate using predictions. And like I said, you can compare each model and decide which one is giving the least rate of error. And apart from this, there are also drawbacks when it comes to this model. Okay. If you have a large data set, this model might take longer time to process the entire thing. Okay. It requires predictability. I mean, it requires scaling. Okay. And it may lead to wrongful predictions, right? Right. These are certain things you can look at KNN classifier. Okay. So here I'm importing pandas as PD and NumPy. Okay. And I have a smaller data set. Then once I normalize the data, that is data frame. Okay. First, I would like to read the data. Then I will normalize the function. And I would like to normalize the data frame considering only the numerical data, right? I would like to check the imbalance as well. Okay. Predictors are also there. There are predictors. Okay. And then you evaluate the model. Would like to train and test. So I will import this library, a particular library called From sklearn.metrics, import accuracy underscore score is what I want. Okay, I would like to print the accuracy score. Okay, and I will say y underscore test. Okay. And these are the column names. These are, I have my row names and as well as the column names. I'm also looking at the error on test train data. Okay. Could you please confirm if you are able to look at this? Okay. All right. So here, right after looking at the error on train data, I'll create a empty list. And then I will run the KNN algorithm. For about 3 to 50 nearest neighbors, and they are all odd numbers. And then I also store the accuracy values that I get from these 3 to 50 nearest neighbors. Forming clusters, right? Okay. So here I do plotting. So you get to see the underfitting, appropriate fitting, as well as overfitting. Okay, we would always, like we can look at overfitting. So it basically stores all the data and then it will classify. So once it looks at the data, and then once you have a different data, a new data, it classifies that into a category and forms a new data. So first, what you do is you check on the K value. Okay. K value of the neighbors. Okay. And then you calculate the Euclidean distance of the number of Ks or the number of neighbors. Okay. And based on the Euclidean distance, you calculate. I mean, you consider the K nearest neighbors based on the calculated Euclidean distance. And then you also look at the number of data points in each cluster. Okay, you have segmented, right? In each cluster, you look at number of data points that you have. And you also evaluate, you also look at it. You assign a new data object which has maximum neighbors. Okay. Only by calculating the Euclidean distance, you get the nearest neighbor. Okay. So it could be 3, your k value could be 3, 5, or 7 for that matter. Okay. If it is a low value, like less than 3, then there might a case be that you will have a outliers in your data, in the model basically. Okay. It doesn't mean that you go with the higher k value, right? For example, in supply chain analytics, so there is this car manufacturing company, okay, which is dealing with a particular car. Okay. So that particular car manufacturing company is advertising to basically sell the car, and they are advertising to people who are not interested basically. Okay. So what is that you look for? You look for the financial status of those customers. Okay. Purchasing power. You might also consider the age of the potential customers, prospects, right? Like we consider these variables. We can also look at maybe gender, right? And then you train the data. And based on that, you predict the test results. Okay. And you do a test accuracy. You also look at creating confusion metrics. And also you predict the test results. Okay. Once you predict the test results, you can visualize the data that you have. And you will have also, you should also visualize the test data, basically test results, right? Let me get this code. So based on the distance, you have to sort. Okay, be it ascending order or in some way. So the benefit of KNN is it gives you a high accuracy compared to other models. Okay, it cannot store large volumes of data. Okay, if that particular person, the variables like salary, age, gender, if they're all considered, and then if they are marketing to a person who is not willing to buy that particular product, like a car, if you look at a car manufacturing company, right? Will he buy that car or will he not buy that car? Right? Something like that. Right? Because there there are few car manufacturing companies, premium ones, who only deal with a handful models of cars. Okay, not like the regular traditional car manufacturing companies. Okay, whose target audience are less. However, they would like to market. Right? For example, see, if the person is visiting the supplier or a retailer, will that customer be a potential customer? Will he be interested in buying that product or not? Okay. So here comes what we call as, okay, we look at data points, we look at few observations, okay, the dimensions, okay, as well as the predictor, okay, and the features, independent variable, or like So, like I said, if you reduce the value of k, for example, let's say k is equal to 1. Okay. So when you have k is equal to 1, whenever you do a prediction, your prediction becomes like unstable. Like it is not that stable equivalently. Okay. Since the k value is 1, it incorrectly predicts the results, right? The outcome. So how can we deal with KNN? So, and also we can look at yes, we also already discussed about the car manufacturing unit. Movies, yes, movies also. What is that you would like to recommend to a person? Okay, if the customer is coming up to the supplier to buy a car, what is that you would like to recommend based on the preferences? Okay, this KNN algorithm will help in achieving these results. Can you think of any other department where this algorithm works, machine learning algorithm works in any other department apart from the manufacturing unit? Sales. Can you think of sales? Can we do it if the data set is large? Can you tackle that challenge? No, it cannot be. It will do. However, it is a time consuming process. The smaller data sets are most preferred, right? You make the k values between the smallest distances. Yes, of course. Even in politics, vote or no vote is what it is doing. And when it comes to data preprocessing, Canon is used to look at missing imputation. Okay, something like missing values. Okay, it will capture a certain pattern, like it will look at a pattern, some kind of let's say a person who already buys a car, will he be able to will he be interested in buying the car? Okay, like customer buying behavior is what it looks at. Okay, that particular that pattern, as well as the primary markets like stock exchange, stock market. Nowadays it is also quite familiar, quite like very famous in the crypto virtual money, right? you know Crypto. So what are the things that it will capture? It will it will let you use it with less data set, right? The lesser the k value, the better it is, the better results you're getting. Okay, it deals with, okay, it gives you recommendations, right? It can predict a pattern, and it is not that reliable with large data sets. Okay, your KNN is also called as lazy learning, right? So if the data set is, let's say you have a huge data, okay, the rate of prediction will also go low, right? At the level of prediction is slow comparatively. KNN can be used in both classification as well as regression models, regression problems basically. So let's say, for example, you have the data which is related to only cars, two kind of, let's say you have data related to trucks and cars. Okay. And there is another vehicle, like it could be a forklift or it could be a earth mover. However, okay, Prashant. All right, Prashant, got it. Okay, it is said that KNN is supposed to be one of the simplest supervised machine learning algorithm, which is used for classification. So the variables that you have is limited. So you might have the variables like truck and car. Either it has to be a truck or car. And to find the nearest neighbor, you have these 2 points. And even in healthcare units, KNN algorithm is implemented. Like if a patient is susceptible for a certain disease or a condition or not, if a customer will be a defaulter or not, right? Any industry for that matter. Will the package, once the package is in transit, will that particular package reach the customer on time or not? Okay, a medical condition can also be predicted. And the data which you have, you should be having a numerical data. First you'll have to convert the data into numerics, and you'll have to select only the features which has numeric values. Okay, that will be taken care in data pre-processing, of course. Okay, that is where your standardization, normalization will come into picture. Or else that might lead to incorrect predictions. So if you consider two products like a truck and a car, okay, there is a certain pattern or like shape or number of tires or the seaters in the car. Based on these features, you'll have to categorize these two products, right? Like the seating capacity of a car and the wheels on a truck, etc. Okay. Speed, performance, I don't think so. Okay. Okay. The boot space in the car and the truck has this container, right? The amount of goods it can carry, the weight, like it is measured in tons, right? Basically the size of the truck. We also discussed about the the drawbacks as well. We'll not focus on the drawbacks yet. And also, if a student can take up, how likely the student will take up science or arts as a major? Will that student take up science or arts as major? So these things can be predicted, right? When it comes to implementation, okay, there are few things we need to consider. Okay, how large is your data? Okay, and what what is the accuracy that you're looking at? So your KNN will handle the data. It will calculate the distance, okay, and it will find the K value or the nearest, okay. You can find the K nearest point and predict the class, and of course look for accuracy. This is how you deal with KNN. In your train test split data, you can decide for yourself on the train test split. Since you have a lesser data, train and test 80-20 will not be a problem, is what I'm assuming. Okay. All right, friends, we will stop our discussion here for the day, and we'll continue in our next session. Okay. All right.